Hello and welcome to the Vibrations and Wave Propagation Laboratory at CU Boulder. I'm going to show around the equipment that we have, and we can talk about some experiments that we have done in the past as well. This is one of the scanning laser heads that we employ every day in our lab to measure vibration, wave fields on different objects. The objects generally are some samples or coupons that we print using 3D printers, or sometimes we prepare using Legos. And this vibrometer is generally capable of measuring wave field up to 25 megahertz, and it also is an infrared technology based vibrometer, so we don't need to pre-treat the surfaces. Over here you can see this unit, which is an integrated unit for this vibrometer. It has data acquisition and all the equipment, CPU, processing, everything that is required to take and post-process the results from the vibrometry. Over here we have a shake table that is capable of actuating 225 pounds of forces, and while it can control the vibrations based on the acceleration as well as the force. So for a 1 pound test equipment, this equipment can provide almost 25 Gs of excitation in harmonic loads, and then if it's a random excitation, it will be automatically reduced based on the RMS values. Over here we have another set of vibrometer equipment. So this here is a vibrometer controller for the fiber vibrometer that is placed here with the robotic arm. So this robotic arm enables us to move this fiber vibrometer's head to the desired location. And we control this using a LabVIEW VI that is built in to accommodate all the functionality required for the scanning purposes. Over here, this whole setup is basically a metallic unit that can help us support heavy equipments or large large structures of which we want to study vibrations. So this whole setup is custom built, it's modular, so we can add or remove components to it as desired. Then we have multiple actuator units. We have some modal shakers which do not need any amplifier. There are some speakers, some piezo discs that can be used for actuation. So far we have looked at various geometries like these 2D quasi crystals. These are 3D printed, made with stereo lithography or SLS, the selective laser sintering techniques. This in particular is a minimal surface that we have worked on. These are quasi-periodic plates with a quasi-periodic pattern made with Legos. This unit in particular has 44 by 44 Lego lattice. And then we are also working on some Moir patterns in the plates, and these can be easily printed using 3D printing technologies. Thank you.